All right. Welcome back to Alteryx Tutorials. I am Mark Thompson. This is Watermark Data. We got a really cool one for you today. It's still a fundamental, but it's certainly starting to be on the edge of a little bit harder one. And this is a geospatial. Today we have a geospatial where we've got customers that need power, and we've got splices from their provider where they can come from. And the idea is that you want to have the shortest splice possible. However, there's a catch. And we have another piece of data over here, and that catch is that it cannot cross any water. And here is a geospatial of all of the water polygons that are in this area. So this is down in the San Diego area, and you've got these customers, and they need power, right? Here are the points. You've got these splice locations where they can come from. Now, how do you get to them the shortest route possible without crossing any water? Let's go ahead and get started. As you can see from the file, very simple file. It's only 7 lines long, and it's already got a geospatial point for the 7 customers. Our other piece of data is here, and there are 5 splice locations, and they already have their geospatial point as well. Next thing we want to do is we want to identify. We want to give these a name. So I put a formula on here, and it's a very, very simple formula. And it simply says we're going to call this type, and we're going to call it cust for customer. Down here, we're going to call it type, but we're going to call it splice. And here we're going to use a geospatial tool, which is find nearest, okay? And the settings in this, we have a spatial object up here, and we have a spatial object from the universe. The target is this T. We've got a spatial object. The U is the universe. We've got a spatial object. And we want to know how many nearest points. Well, there are only 5 potential points for our targets here. There's only 5 splices, so we're not going to do more than 5. And the maximum distance is 20 miles, and this is a little bit arbitrary, but we want to make sure we catch any and all. So that's easy. When we run this, we get 2 outputs, those that match and those that don't. In this case, we don't have any. We set that at 20 miles. You're going to catch everything. When you look at this, here we've got 5 matches, right? On 7 points. So we basically matched everything on everything. There are 35 matches. We haven't put in the criteria for the water yet. The next thing we want to do here, however, is we want to create lines between all of these splice points, the customer spatial and the splice spatial. So we've got customer 1, and you can see we've got splice 1, 2, 3, 4, 5. And over here, it tells us the distance in the cardinal. We don't necessarily need to know that just yet, but we'll use that going down the line. When we run this, this is the data we get. Now we want to come here, and we want to create lines between each of between this customer point and this splice point. And so we've got a formula that is a spatial, create lines, and what are the two endpoints for the line? Customer spatial and splice spatial, right? And this is a geospatial object. When we take a look at that, and we're going to browse on that for a moment, you can see out here that we now have a spur line. We now have a new spatial object that was created from that spatial formula. And when we look at the picture of that, here's what it looks like. All of these customers and all of these splice points, all having lines. Now, the next thing we want to do is we want to bring in our file with the water spatial. And there's 274 different records, all of these polygons over here. 274 274 polygons in this file. And the tool that we're going to use here now is Spatial Match. And again, these are all coming from the Spatial menu. And Spatial Match says we're going to take these spur lines here, and we've got these, that's the target, that's the T, and we've got this universe, that's going to be the water polygons, and where a target touches, that's where the target, our spur lines, touches or intersects the universe, that's our water object. We want to match that. We want to match that. Now here is the deal. If you take a look at this, it's got a matched and an unmatched. Well, the reality is what we want is the unmatched. So when we say that we've got a spur line and we've got a spatial object here and we're matching them, any place where the target, any place where the spur line touches or intersects water, match it. Well, that's the result here. So these are all of the lines where it touches or intersects water, which means you're left with your unmatched where it does not intersect water. And if you go down here and look at this browse, you can see this combination of lines, okay? Now we're getting somewhere. Now we have a situation where we can isolate down. Here are the lines that can do the job and not touch water. What is the next piece that we want to bring into this equation? Well, the next piece is let's take those lines, those spatial lines, and say which one of those are the closest. So you'll notice here that I've got a customer 1, 2, 3, 3, 4, 4, 5, 5, 6, and 7. That means the customer 1 and 2, there was only one line that worked. For customer 3, there are 2 lines. Customer 4, customer 5, there are 2 lines. Customer 6 and 7, there's only one line. The next thing we want to do is let's sort them by customer and sort them by distance ascending, so we get the shortest one up top. And now we're going to take and we're going to put a sample tool on this. Put this sample tool on this and say, okay, the first n rows, we only want the first one row, and we want it by customer label. We're going to group this column by customer label. So we're only capturing the first line in each of those, organized by customer label. Okay, now we do this, and the output from that now brings us down to only 7 lines. Next thing we know, and you people all know this about me, I like to clean it up and let's get rid of the stuff we don't need. So we've got customer 1, 2, 3, 4, 5, 6, 7, and we're going to use fiber splice 5 and 5 for 1, 4 for here, 1, 3, splice 1, 3, and 5. And when you look at the results of this, here we go. Here is going to be each of the splices that we need for our given customers that are going to be the shortest route to our 7 customers from our 5 splice locations that do not cross water. I am Mark Thompson. This is Watermark Data. These are Alteryx tutorials. If you like what you heard today, please hit like, please hit share, and let all your friends know. I hope you enjoyed. I will talk to you next time.